Let's now look at some structured data. An example of a database that stores songs, their lyrics, the albums that contain those songs, and the artists who may have sung them. This example is taken from a Sigmod paper which talks about searching relational databases as opposed to using queries. Let's see what it would take in SQL to get the albums with world in their title. One might write a SQL such as this, which is an Oracle SQL. You select star from the album table where the title contains the string world. Things get a little more difficult if one now wants more information from this complex schema. So let's ask, how many SQLs will it take to retrieve the names of each artist and the lyrics of every song in an album that has world in its title? Take a look at the schema and answer the question. Please avoid complex joins which join every single table in this schema. You could do that, but we're trying to get at how many simple queries will it take. Here's how we could do this. We first retrieve the album from the album table. Then we have to traverse this table to find out all the songs in that album and their lyrics from this table. We also have to find out all the artists that compose this album, B1, from the artist album table, and then retrieve the actual artist names. Each of these can be done with a single query if you allow a one-table traversal join. Otherwise, each of these will require two separate queries. Quite complicated for doing something which is easy to do if one just had a Google-like search on this database. Unfortunately, that is quite difficult to achieve. Imagine if we had a search interface so that we could issue a query like off the world, since we didn't really remember the exact title of the album. The SQL approach would end up missing partial matches, such as the album titled World or the album titled Off the Wall. Next, the schema needs to be understood quite carefully in order to issue the multiple SQLs needed to retrieve the information that we want. Sometimes a complex join might be needed. But there's even more. Suppose there were multiple databases, each with a different schema, and partial or duplicated data across these databases. And suppose the keys used in each database were different, with no relationship to each other. Most importantly, suppose we have some unstructured data in documents, like text files which contain the lyrics or biographies of artists, and the others in structured databases like the lyrics database. How to search both of these together? When you search a set of documents and you get an album, can you find the songs in that album by looking up the lyrics database, and vice versa? The point I'm trying to make is that searching structured data well in a query-like manner remains a research problem. The fact that so much structured data is being accessed using applications is only because a lot of complicated programming using SQL goes into accessing that data. Let's conclude now by asking whether looking is the same as searching. When we look around a room, for example, and recognize objects and people doing activities, we're not really searching for anything. Or when we're browsing a bookshelf, or flipping the pages of a book, or even looking at some data, like some time series, or a histogram, or charts, to see if there might be any hidden patterns in the data. In the first case, while seeing, we are visualizing a scene. Computationally, this involves techniques such as clustering and classification. In the second and third examples, we're trying to get a feel for a document, a collection of documents, or some data, which requires techniques such as automatically summarizing documents, discovering the topics in documents, and discovering interesting correlations in data without direct intervention. Each of these are deep research areas of current interest, and we'll get into them as we go beyond looking to listening, learning, connecting, and predicting. So see you next week.